For a reaction, half A gives 2B. The rate of disappearance of A is related to the rate of appearance of B by the expression. So for the given reaction, we got half A will give 2B. So we can write the rate as minus 2 dA with respect to time, which is equal to half dB upon dt, and minus dA upon dt is equal to 1 by 4 dB by dt. So this will be our perfect rate reaction. So option A is the correct answer. So our next question is, for the reaction 2N2O5, which is gaseous, will give 4N2NO2 gas if the concentration of NO in 100 seconds is increased by 5.2 into 10 raised to minus 3 meter, then rate of reaction will be. So in the given reaction will be 2N2O5 will give 4NO2 plus oxygen. The rate of reaction with respect to NO2 is equal to 1 upon 4D NO2 by dt is equal to 1 upon 4 into 5.2 into 10 raised to minus 3 upon 100. This is the rate of NO2 by dt, which is equal to 1.3 into 10 raised to minus 5 meter per second. So option A will be the correct option. So our next question is, for the reaction nitrogen gas plus 3 hydrogen will give 2 moles of ammonia under certain condition of temperature and partial pressure of the reactants. The rate of formation of ammonia is 0.001 kg per hour. The rate of conversion of hydrogen under pressure is option A 1.8 into 10 raised to minus 4 kg per hour, B 0.0015, C 1.52 into 10 raised to 4, D 1.82 into 10 raised to minus 14. So in the given reaction will be N2 plus 3 moles of hydrogen will give 2 moles of ammonia. So we can write the rate of the reaction will be minus N2 upon dt, which is equal to 1 upon 3 H2 upon dt. Here will be minus sign as both are reactant, and the product will be ammonia upon dt. So the rate of hydrogen dissociation is equal to 3 by 2 into 0.001, which is equal to 0.0015 kg per hour is a given answer. So option B is the correct answer. So our next question is, the term minus dC by dt in a rate reaction refers to A. Concentration of the reactant, B. Decrease in concentration of the reactant with time, C. Increase in concentration of reactant with time, D. Velocity in constant of the reaction. So let us consider a reaction. Formation of ammonia by degradation of nitrogen will give 2 moles of ammonia. This is formation of ammonia, that is increase in concentration of ammonia with time. So we can write this as 1 upon 2 NH3. And for degradation of product like ammonia, we have to put a minus sign as the concentration decreases with time. So a minus sign with d of N2 upon dt as it is with respect to time. So decrease in concentration with respect to time minus dC by dt is the correct answer. Our next question is, for the reaction nitrogen plus 3 moles of hydrogen gives 2 moles of ammonia if rate of ammonia by T is equal to 2 into 10 raised to minus 4 mole per liter per second, the value of minus H2 by with respect to time would be. So in a given reaction, this we can write the rate as minus dN2 upon dt, which is equal to minus 1 upon 3 hydrogen by time, which is equal to half ammonia by time. Therefore, hydrogen upon time is equal to 3 by 2 into ammonia upon time, which is equal to 3 by 2 into 2 into 10 raised to minus 4. So answer will be 3 into 10 raised to minus 4 mole per liter per second. So option B is the correct option. So our next question is, a gaseous hypothetical chemical equation 2A is equal to 4B plus C is carried out in a closed vessel. The concentration of B is found to be increased by 5 into 10 raised to minus 3 mole per liter in 10 seconds. The rate of appearance of B is. The increase in concentration of B is given to us as 5 into 10 raised to minus 3 mole per liter, and time is given as 10 seconds. So the rate of appearance of B is equal to increase in concentration of B upon time taken. So this is equal to 5 into 10 raised to minus 3 mole per liter upon 10 seconds, which is equal to 5 into 10 raised to minus 4 mole per liter per second. So our option A is the correct option. So our next question is, the rate of reaction is double for every 10-degree rise in temperature. The rise in reaction rate as a result of temperature rise from 10 degree to 100 degree is A 112, B 512, C 400, D 614. So our given formula will be the KT plus 10 upon KT, which is equal to RT plus 10 upon RT, which is equal to 2. For increase of temperature to 90 degree, that is 9 times, the rate increases by 2 raised to 9 times, which is 512. So option B is the correct option. Our next question is, the rate of a reaction A increases with increase in temperature, B decrease with decrease in temperature, C does not depend upon temperature, D does not depend on condition. So for our given reaction will be, when both rate and rate constant increases with temperature, R is equal to K reactant raised to N, where R is the rate, K is the rate constant. So K is equal to A E raised to minus EA upon RT, where EA is the activation energy. So as both are dependent on temperature, so rate of the reaction increases with increase in temperature. Option A is the correct option. So our next question is, the rate of reaction increases with temperature due to A decrease in activation energy, B increase in activation energy, C increase in collision frequency, D increase in concentration. When heat energy is supplied, kinetic energy, which is Ke, of the reactant molecules increases. When the kinetic energy increases, this will increase the number of collisions, which will ultimately enhance the rate of reaction. So increase in collision frequency due to increase in kinetic energy is the correct answer. In the synthesis of ammonia from nitrogen and hydrogen gases, if 6 into 10 raised to minus 2 mole of hydrogen disappears in 10 minutes, the number of moles of ammonia formed in 0.3 minute is. So in the given reaction, we can write this as nitrogen will form 3 moles of hydrogen. Nitrogen plus 3 moles of hydrogen will give 2 moles of ammonia. With this, we can write the rate as minus dH2 upon dt is equal to 3 by 2 dNH3 by dt, or ammonia with respect to time can be written as minus 2 by 3 dH2 by dt. As the rate of hydrogen is given, so 2 by 3 into 6 into 10 raised to minus 2 upon 10 in 10 seconds. So ammonia will be 0.4 into 10 raised to minus 2 into 10, which is equal to 4 into 10 raised to minus 2. In 10 minutes, number of moles of ammonia is this. Then in 0.3 minutes, the number of moles will be 4 into 10 raised to minus 2 into 0.3 divided by 10, which is equal to 1.2 into 10 raised to minus 3. So option B is the correct answer. So our next question is, the rate of chemical reaction doubles for every 10-degree rise in temperature. If the temperature is raised by 50 degree, the rate of reaction increases by about. For rate at 50-degree rise in temperature upon rate at T1 degree rise is equal to 2 into change raised to change in temperature upon T1 temperature. So we can the value as 2 raised to change in temperature will be 50 and T1 temperature is 10. So by cancelling this we get 2 raised to 5, which is equal to 32 times. So the rate of the reaction increases by about 32 times. Option C is the correct answer. Our next question is, the rate of the reaction will give product at the initial concentration of 3.24 into 10 raised to minus 2 moles. The order of the reaction is 9 times its rate of another initial concentration of 1.2 into 10 raised to minus 3 moles. So as the order is 9, so we can write the equation as 9R, which is equal to K into initial concentration as 3.24 into 10 raised to minus 2 raised to alpha. R equal to K into 1.2 into 10 raised to minus 3 alpha. Let this be equation 1 and this with another initial concentration on order 1 be equation 2. Dividing equation 1 by equation 2, we get 9R upon R, which is equal to K 3.24 into 10 raised to minus 2 alpha upon K 1.2 into 10 raised to minus 3 raised to alpha. By solving this, we get 3 raised to 2, which is equal to 3 raised to 3 alpha. By solving this, we can equate the value of alpha as 2 by 3. So option D is the correct option. So our next question is, in a zero order reaction, for every 10 degree rise of temperature, the rate is doubled. If the temperature is increased from 10 degree to 100 degree, the rate of the concentration will become. Let R be the rate for 100 degrees Celsius and for R 10 degrees Celsius is equal to 2 raised to change in temperature upon initial temperature, which is T1. So R 100 degree upon R 10 degree is equal to 2 raised to 100 minus 10 upon 10, which is equal to 2 raised to 9. On solving this, we get 512 times. So the rate of the concentration will become 512 times. Option B is the correct option. Our next question is, the rate law for a reaction A plus 2B is equal to C plus 2D will be. The rate law is raised to the powers which are given as coefficients of the reactants. So the coefficient of A is 1, B is 2, C is 1 and D is 2. So we can write the rate of the reaction as rate equal to K into A, which is raised to 1, and B, which is raised to 2. So the rate law can be written as this, and option B is the correct answer. In the reaction, 2N2O5 will give 4NO2 plus O2. Initial pressure is 500 atmosphere and the rate constant K is 3.38 into 10 raised to minus 5 per second. After 10 minutes, the final pressure of N2O5 is A 490 atmosphere, B 250 atmosphere, C 480 atmosphere, D 420 atmosphere. So initial pressure PO is equal to 500 atmosphere. So K is equal to 2.303 upon T into log to the base 10 of PO upon PT. K is 3.38, which is rate constant, into 10 raised to minus 5 equal to 2.303 upon 10 into 60, and log of initial pressure is 500 and final PT, which we have to find out. So on solving this, we get 0.00880 equal to log of 500 upon PT, which is equal to 500 upon 1.02. On solving this, we get 590 atmosphere as our P2 final pressure after 10 minutes. So option A is the correct answer. The rate law for the reaction sucrose plus water in presence of H plus ions will give glucose plus fructose is given by. As it is pseudo unipolar reaction, the rate is equal to K into sucrose into water raised to 0. As water is present, it is pseudo unimolecular reaction, so option B is the correct answer. Our next question is A plus 2B will give C plus D if minus dA by dt is equal to 5 into 10 raised to minus 4 mole per liter per second, then minus dB by dt is. So in a given reaction, A plus 2B will give C plus D minus dA by dt is equal to 5 into 10 raised to minus 4, which is equal to minus half dB by dt is equal to 5 into 10 raised to minus 4. So by solving, we get dB by dt is equal to 10 into 10 raised to minus 4 is equal to 10 raised to minus 3 mole per liter per second. So option D is the correct answer. So our next equation is the reaction 2NO plus O2 will give 2NO2 is of first order. If the volume of reaction vessel is reduced to 1 by 3 times, the rate of the reaction would be. So in the given question, the volume is reduced to 1 by 3 times, and this is the following equation. When the volume is reduced or changed to 1 by 3 times, then concentration will become 3 times. The rate of the reaction for first order is directly proportional to concentration. So as concentration becomes 3 times, the rate will also increase by 3 times. So option C is the correct answer. So next question is, if 60% of the first order reaction was completed in 60 minutes, 50% of the reaction would be completed in approximately how many minutes? So given equation would be K equal to 2.303 upon 60 log of 100 upon 40 equal to 0.152. So K will be 0.693 upon T half, that is 50% will be. T half is equal to 0.693 upon 0.152, which is our rate constant. On solving this, we get 45.37 minutes. So option B is the correct answer. Rate constant for a reaction H2 plus L2 give 2HL is 49. The rate constant for a reaction 2HL will give H2 plus L2. So the reaction this is a reversible reaction of this. As both are reversible reaction, the rate also get reversed. So as the rate of first reaction is 49, so the rate of other reaction will be 1 by 49. So option B is the correct answer. A reaction that is of the first order with respect to the reactant A has a rate constant of 6 raised divided by minutes. If we start A is equal to 0.5 mole per liter, when would A reach the value of 0.05 mole per liter? So in the given reaction, we know that the first order kinetics K is equal to 2.303 upon T log of A upon A minus X. A minus X is equal to 0.05 mole per liter, 6 equal to 2.303 upon T log of 0.5 upon 0.005 A upon A minus X, or we can write T equal to 2.303 upon 6 log of 0.5 upon 0.05. So 2.303 upon 6 is equal to 0.384 minutes. So option A is the correct answer. For a chemical reaction A to B, it is found that the rate of reaction doubles when the concentration of A is increased 4 times. The order of A for this reaction is, as R is equal to K A raised to M, or we can write it as 2R is equal to K 4A raised to M. So half is equal to 1 by 4 raised to M. On solving, we get M is equal to half. So option C is the correct answer. Which of the following formula represents a first order reaction? For first order reaction, T half will be 0.693 upon K, which is rate constant, and a complete reaction will be K equal to 2.303 upon T log to the base 10 A upon A minus X. So option C is the correct answer. It represents the first order reaction. The first order rate constant for decomposition of N2O5 is 6.2 into 10 raised to minus 4 per second. The half period for the decomposition in second is, T half is the half life, which is equal to, for the first order reaction, is 0.693 upon K. So rate constant is K, which is equal to 6.2 into 10 raised to minus 4. On solving this, we get 1117.7 seconds. So option A is the correct answer.